All right, so we are about to start our second layer, so the top layer of solar panels. We've got the first layer actuating in and out. They're hooked up. They're charging the battery as we speak. It is winter and the sun is way down low, so we're only getting, I think, about 1,000 watts out of a possible 1750, which is, we looked some stuff up online and that's pretty normal. So anyway, this one's going to help us get the panels up there. We've got a time lapse going. We'll see if that turns out too. So, but we're going to attempt to heat them up there, and then Michelle and I will climb up, pick them up, and drop them in their places. We'll see how it goes.
Okay, so we just got the last two of the upper panels up in the frame, and now we're going to start putting our clamps on to secure it up.
All right, it's the end of the day and the sun's almost completely shadowed by the house, so we are literally not making any solar, but we're up here trying to connect them all up, finish them up. And the way we're wiring these is we're just getting these out of the way because the other panel swings up under. So if you look over there, you'll see how close they really are. And so we're just trying to get them out of the way so that they will clear and not pinch or anything back here. So what we do is we're just zip tying them up to this structure right here, and then just going down and bolting, and we can make the electrical connections under here because there's plenty of room and there's plenty of this under there to go all the way down. So anyway, that's what we're doing right now. We're gonna finish hooking everything up and then run the line all the way down this track just like the other one and into that combiner box, and then we should have full solar power. So we should have the full power of all of our panels. But actuators also still just need to be hooked up. They're just here. We're just doing them manually for now with that drill battery. But all right, so we're out here trying to see how tall this thing is. So Michelle's putting up the measuring tape. All right, babe, I'm gonna call that's 11 foot even. It's just shy of, actually.
Okay.
It's like 131 3/4.
Okay, let's try the other side.
Okay, I'm gonna do the other side. So we're doing it to the top of these bolts. So to the top of these bolt heads. So that we get the absolute tallest we can be. So here comes the measuring tape. Yeah, that's maybe 132.5. 11 foot and a half. All right, well, I'm gonna get down.
Okay, so one of the things we wanted to show you was how we can still open our vent fans with the solar panels in place. So that's actually how we determined how high everything was going to be, was to be the lowest it could be, the upper panels to be the lowest they could be, while still opening our vent fans all the way. So if you can see, Juan's opening it, that's at full, the fan is fully open, and there's just a tiny bit of clearance between that and the bottom of the upper panel. So when the lower panels are slid out, we can fully open our vent fans. Okay, so now you can see our lower panels are slid in, and we can actually still open our fans, I would say about 2/3 of the way. So not quite all the way, but almost. So even when our panels are in, if we're driving or if there's bad weather or something like that, or obviously at night, we can still have our vent fans almost all of the way open. So this was a major consideration in how we designed the height of our rack. Was we still wanted our fans to be fully operational and functional so that we can use them whether the lower panels are slid in or slid out.
All right, so we're down in the power bay again. We had to make some modifications in here because we found out that inside we're gonna need 48 volts because we're gonna do a 48 to 24 volt converter in what we're calling the tech cabinet. So the tech cabinet is gonna be on top of the refrigerator probably. So what it will house is it will house all of our monitors. So our color control GX, it will house our BMS, the little screen for the BMS that shows us our battery voltages and state of charge and temperatures and all that for the battery system. It will also house our tank monitors as well as the actuator control for the solar stuff, and probably all our Wi-Fi stuff, all our internet stuff, our boosters and things like that. That may be a little much, I don't know, we'll see what we can fit in there, but we needed 48 volts in there to be able to power the actuators. So in this cabinet we have these two terminals are where our main 48 volts, and we've tapped in a new line, and you can see these cool covers. A friend of mine, Travis, made these for me, and we've got them installed, and so you don't accidentally cause a short across these posts that we're sticking up. So it's a little bit safer in here. So we're gonna run 48 volts up inside, and it will run approximately where the refrigerator is. In there we'll have a 48 to 24 volt buck converter. We'll screw all that in. We'll get it all kind of temporarily in place. When we build something out, the wires are a little long and they're a little messy because when we build something out, we'll cut everything to length and trim everything up. But for now, we just want to make sure it's working, and we want to be able to control our solar panels to be able to deploy them and things like that. So we've put in a new circuit breaker. It's going inside. We've already run it. All right, so we've run wires through our conduit up over the roof, and then down. We followed the same wire path that we followed with the solar panels, and now we're going to wire up the actuator. And so now we've got to remember which one is positive, which one is negative. So we've chosen red, blue for that actuator, and then green and yellow for this actuator. So I think we're going to do yellow positive, green negative, and so those will have to flip-flop depending on if the actuator is going in or out. So we've run 14 gauge cable. It should be plenty. This thing should only draw 5 amps at the most, and so we've got a 5 amp circuit breaker as well that's going to go in the space above the refrigerator. But right now we're just kind of pre-wiring everything, getting everything set so that we can actually control this thing and test it out and everything before we get to the final stage. Anyway, we're going to solder these up, and we've got we have shrink wrap that is marine grade, which has this glue stuff that forms all around it. So we'll be doing two things of heat shrink over it so it's nice and watertight. We'll solder them all up.
Okay, so after we got the actuators all hooked up, we knew we wanted to protect especially this back end with a motor on it that sticks out. So we built this little shelter for it. So what we decided to do was build it out of some real thin aluminum sheet, and we created a paper template first and folded it such that it's all one piece. And we practiced it with paper to make sure we got the size right. And then we just riveted all the seams together. And then we supported it with just some, I think that's just 3/4 inch aluminum angle. And then we used our trusty 3M 5200 and we glued it onto this side of the upper rail here. And then on the other side, it is glued onto the stand right here. And so it's open on the bottom, so you know there's still airflow in there, and this is actually rated at IP65, so it is actually should be okay in, you know, light weather, but we wanted to protect it from the sun and rain and just give us a little bit more peace of mind with it. So this seems to be really sturdy and holding up well, and we think this should do a pretty good job of protecting them.
From the roof, we now have 4 cables coming down, and these are for the actuators here. And then these 2 are the solar output cables. So they're actually hooked up here and then going down into the bay. We've also brought up the 48 volt lines, so we've brought a couple of 48 volt lines up. They're not live yet because we haven't turned the switch on yet, but there's a couple 48s. We split those so that we can power our color control and power this buck converter, which will give these 24 volts. But we don't just want to wire it directly, so what we've done is we've purchased this little it's a little actuator controller, and so what it'll do is it will reverse the polarity for us, like in and out. There's a little switch on the side to go in or out, and in addition to that there's a remote, and so the remote you see has 4 buttons, and I think like C and D are, as long as you keep pressing it, it'll keep going out. D is as long as you keep pressing, it'll keep coming back in. And then A is, it will just turn it on for, I think, like 2 minutes or something and then turn it off. And same with B, it'll turn it on to bring it back in for 2 minutes and then turn it off. So that's what we've got planned for today. It's a pretty cloudy day today. But it is Arizona and it's getting warm, and so our solar is fluctuating big time. So we're still getting used to how much power can we expect and what does all that look like. So it's been interesting to watch because we have the little monitor up here, and we're currently running our AC, so there's actually a load on it. And so trying to set kind of the float voltages and all that, trying to get everything sort of tuned so that we can use the system effectively. Anyway, we're going to go ahead and install this so we can deploy our panels and have them on a remote and all that good stuff. And then we'll check back in when we finish that. All right, so the moment of truth. It's time to test, like, if we hooked everything up. I'm too nervous to do the A and B, so we'll start with C and D. So C should push it out, so here we go. Maybe it's not.
Did you not turn a switch on?
I don't know. All right, so we've wired everything up. We are about to test it. So we can retract these panels in one of 3 ways. So the first way is this remote. So this remote, C and D are momentary switches. A and B are locking or latching switches, which means that you just press it once and it'll do its thing. There's also a switch inside on the side of the little controller, which will drive them in and out depending on which way you toggle it. And lastly will be our bus automation stuff. So we'll have, in the future, not now, we'll have a series of sensors and some logic that determine, like if the battery's full, we don't need the solar panels deployed, or if it's windy, it should bring the solar panels back in, or if the engine is on, it should ensure that the solar panels are in, things like that. If it's nighttime, the solar panels should be brought in. So there's a series of logic that we're going to put that to kind of minimize the risk of having the solar panels out. So anyway, here we go. We're about to try it, and that's the temporary one. So it looks like it's coming out just fine. I'm gonna try the other one. So let's try that. So there, I just pressed it and it should come out, and I'm kind of ready to press the button again if something goes wrong. So hopefully it doesn't hit the house. Okay, they're out. So they're deployed. All right, so as far as weather goes, we put in this system roughly 3 weeks ago or so, and we have had a ton of rain in Arizona. It's been record rainfalls. We've had rain and cloudy and just really odd weather for Arizona. Even today, which is a relatively clear day, it's all this wispy kind of, almost like just a hazy, overcast, cloudy day. So this has been the clearest it's been for probably the last 3 weeks. And so this is the kind of weather that we're pulling our current data from, because this is what we have right now. So clear days will be coming, but this video needs to go out. So this is what we're working with. So the days we've had have either been very thick clouds and raining, or it has been like, and this has been one of the better days. So anyway, just for reference on our numbers, this is what the days look like. All right, it's the end of the day, and this is our second day of trying to get a full assessment of, let's deploy the panels and then leave them open and see what kind of power we get. Now it is February, so the sun is pretty low. It has been extremely overcast, so you can even see today that the clouds are, it's pretty cloudy, so we're not getting as much solar as we will get on a clear day. So we have been drawing our numbers though, and from an initial power audit, so when we first did it, we thought, you know, we did a couple things. The refrigerator's going to be running, it'll be using about 1 kilowatt hour. The inverter has some parasitic power draws. We're going to be running several home automation type computers and things like that, lights, pumps, whatever. So the number we sort of just rough napkin type sketch we came up with was 6 kilowatt hours. If we could generate 6 kilowatt hours during the whole day, then we could not use as much power as we want, but not worry about power. And so over the last 2 days, we've been running our AC at night. So we've been running our air conditioner during the night to try to run our battery down. And then the first night we ran, I'm sorry, it's the heater, because it's winter right now and it's about 40-ish degrees at night, 40 to 44. And so we've been running the heater and setting the inside at 80 degrees so that the heater is constantly running that entire time. And our heater at full bore uses about 1,000 watts, and that's our mini split. So it's about 1,000 to 1,200 watts that it uses when it's, you know, trying to heat the inside. And since there's no insulation or anything, it does have a hard time heating it from 40 to 80 degrees inside. So it does run pretty continuously. So the first night we ran our battery, and we ran it for a while, and then the battery got down to, I think, the low 60s. I'll have to check my numbers for sure. Then we ran it again last night. We ran it for longer. We ran it for like 9 or 9.5 hours, just continuously running. I ended up shutting it off at like 1:30 or 2 in the morning when I had decided I'm going to go to bed and I don't want to leave it on all night. Anyway, that drained it down to, I think, in the high 50s. So our battery was in the high 50s. What we wanted to do was create a situation where the solar charge controller didn't go into like float mode or didn't turn off because the battery was full or whatever. We wanted to see how much energy we could collect during the day. And so over the last 2 days, I'll show this on the screen actually right next to me, but we collected 10.55 kilowatt hours yesterday, or the day before, and 9.93 kilowatt hours last night. So almost 10 kilowatt hours over that entire, over the course of the whole day. And both days have been really overcast and not ideal for solar at all. So we've been doing, we think if our goal was to hit 6, we've definitely hit 6. All right, so that's going to put an end or a wrap on our solar videos. We have been really excited to have you guys join along while we designed it in our driveway on that crazy wooden scaffolding, and then to see it come to fruition, and it's been working, and it's really been working great. We've had it in relatively windy conditions, and we've had it on for a few weeks now, and we've driven with it. We drive the bus twice a week to take it back to the place where we park it and to bring it here, and so we do drive it twice a week, and there's no noticeable change in the way it drives, and there isn't any, it doesn't make any noise, or it doesn't make any wind noise or anything like that. So we are happy to report that the performance of it is actually exceeding our expectations. So there is one last project left, and that is putting the wind brakes on the side and on the front. And we're still kind of thinking about that and thinking how we're going to solve that problem. We haven't come up with a good solution yet. But there's other projects that we need to move on to, and so we're going to kind of be thinking about that in the back of our mind, and we'll tackle that when the time comes. But we're excited to finish up the outside and then get to the inside and actually start making the living space a reality. So we're really excited about that. So we wanted to say thank you for joining us and for all your encouragement and support. It's been a lot of fun to have you guys along for the ride, and it's been working great.